But what you need to really remember is that the denominator is what root you're taking. If it is a 2 in the denominator, it's the square root. And we're used to square roots because square root means what number times itself gives you that. Like the square root of 9 is 3 because 3 times 3 is 9. The fourth root means what number times itself 4 times gives you that. People don't go around memorizing fourth roots. We memorize square roots. We memorize a few cube roots. Like I know the cube root of 27 is 3 because 3 times 3 times 3 is 27. And I know the cube root of 8 is 2. But other than that, I don't memorize my cube roots. I used to know 1 through 10 by heart, but if you got a calculator, you're good to go. So what you need to remember is that the 4 is the denominator, so that's what root we're taking. The 3, the numerator, is the exponent. So you can write it either way. You can put it in parentheses with the power on the outside of the parentheses, or you could put it around the entire thing. However, let me in a different color show you something that is wrong. If you wrote the fourth root of 10r to the third, that is wrong because that just puts the third power on the r and not the 10. And since it was in parentheses, the 3 also has to go on the 10. Does that make sense? So this is wrong, so I'm going to mark it out so you don't think it's the answer. Same thing over here. 3's in the denominator, so that's a cube root. The 5's in the numerator, so that's the exponent. Any questions? All right, so now what I want you to do is I want you to try number 7. It's going in reverse. It's starting in radical form, and you've got to switch it to exponent form. So try number 7. You're starting with the answer going back to this. All right, so 6x, everything's around the 6x, right? Which means I need to put the 6x in parentheses. Because that makes sure the power is to everything. If I don't put in parentheses, it's just going to the x. What root is this? Like what's above the square root symbol there? 3. So it means it's the cube root. Well, the root always goes in the denominator, and the power always goes in the numerator. So which answer is the right answer? B. Now, one thing I don't like about this question, they made it too easy. There's only one answer choice that even had a 6x in it. But know that on the EOC, they could do this, no multiple choice, and make you type it in. Okay? So I want you to know some test taking skills and know how to do it with multiple choice, because let's be honest, a lot of them are multiple choice, but there are several that are also not multiple choice. Now, let's look at number 8, and then we're going to switch gears. This power of 2 is only on what? B. So this is going to be a little bit different. 2 ways that this can be written. This can be written as 6 to the 1/3 and B to the 2/3 because they're both under a cube root. Or I can put what's there in parentheses and raise it all to the 1/3 power because cube root means 1/3 power. Which one do we have in our answer choices? This one.
Wait, what? I can't see that. It's just too.
There it goes. You want me to zoom in some?
Yeah, I can't see it at all.
Is that a little better? I'll switch back to my other pen. All right, there is a note at the bottom. I'm telling you this, it may not stick in your brain. You need to know this for the common assessment. You need to know this for EOC. It is one question on the common assessment. If you remember what I'm getting ready to tell you, you will get it right. It doesn't take any work. Okay? but you got to know it. So I will probably try to remind you again before the EOC, but I may forget. So I'm going to explain what it means, so maybe it'll stick. But even if you don't understand what it means, you can still know the answer. Polynomials. Remember, polynomials are when you're adding, subtracting variables, constants, exponents. But the one rule about polynomials is you cannot have a letter in the denominator. If you have a letter in the denominator, a variable in the denominator, it's not a polynomial. That's the only rule, really. Well, you can't have an exponent either, but we don't have the exponent. You can't have a variable in the exponent. You can't have a variable in the denominator. So when I look at this, it says polynomials form a system of similar to a system of integers, in that polynomials are closed under the operations of addition, subtraction, and multiplication. What does closed mean? You can't see what I'm underlining because I had zoomed in so much. Closed means polynomials will be closed under an operation if the operation produces another polynomial. So that means if I add two polynomials, do I get out a polynomial? Let's try it. 3x plus 4x is 7x. Is 7x a polynomial?
No.
Yes, it is. If I subtract them, I also get a polynomial. If I multiply them, I get a polynomial. But if I divide them, there could be a variable in the denominator, correct? So that is why polynomials are not closed under division. And what not closed mean, it means if you divide two polynomials, you might not get a polynomial for your answer. That's what it means. So in order to be closed under that operation, it means if you do that operation, you'll get still a polynomial for your answer. The way it's going to be on the test, it'll be one of two ways. It'll either say, which of the following operations is polynomials not closed under? Addition, subtraction, multiplication, and division. And which one would you circle? Division. Or it could say, which of the following is it not closed under? And it'll give you an example where two of them are being added, two of them are being subtracted, two of them are being multiplied, or two of them are being divided. And you pick the one that's being divided. Okay? It's not closed under division. Because if you divide two polynomials, sometimes you don't get a polynomial. Turn the page. I want you guys to look at number 11 for a moment. It says error analysis. Describe and correct the error in finding the product. Somebody did some work there. They were multiplying r plus 6 times r minus 7, and they showed their work over on the right-hand side. Where did they make the mistake? I want everybody to go through the steps and just kind of underline where you think the mistake is. Don't say it out loud. Just go through the steps and see if you can underline where you think they made the mistake. All right, now I'm going to cover up what the work they did. If I told you to multiply these two, what would you do if it was you doing it? Elena, what would you do?
I would say R times R.
So she's saying she would distribute that R. She'd do R times R, and then what? R times -7, and then 6 times R, and then 6 times -7. All right, so let's look. They did R times R, and then they did R times 7. Is that what she said? What did she say? She said -7. Same thing happened over here. They did 6 times 7 instead of 6 times -7. So if I called this step 1, step 2, and step 3, which step would you say they made their mistake in? Step 1. They should have multiplied by -7. The rest of it looks good for what they did wrong, but they messed up on the very first step. All right, we're going to look at number 13 together. It says calculator. The width of a calculator can be represented by 3x plus 1 inches. The length of the calculator is twice the width. What does twice mean? Times 2. Write a polynomial that represents the area. So I'm going to label this calculator over here. The top is 3x plus 1. The side is twice that. So that is 2 times 3x plus 1. Does everybody agree with that? It said twice, so I'm just multiplying it by 2. And then they want me to find the area. How do you find the area of a rectangle? Length times width. Well, before I multiply them, wouldn't it be easier for me to distribute that 2 first? What's 2 times 3? So that would be 6x, and then 2 times 1? 2. Because it would be a lot easier for me to multiply it by 6x plus 2 than both of those. So I'm going to put 3x plus 1 times 6x plus 2 to find the area, because that's length times width, because area of a rectangle is length times width. So you take a moment and see if you can multiply those two together. Any questions there? If you prefer doing the box method where you like draw them like a box and put the little lines in, it look kind of like lattice and fill it in that way, you can do it that way. Either method works.
Why is that 12x in there? What?
Because when I multiplied them here, I got a 6x and a 6x, and what's 6x plus 6x?
Well, why is it squared in that?
3x times 6x is 18x squared. Because x times x is x squared. All right, let me tell you what your homework is tonight. Some of you got zeros last night. You don't need another 0, so let's make sure we're doing this.
Did I do that or no?
Did you do it?
Yeah.
Then you didn't get a 0. I'll turn it back. Let me show everybody what their homework is. All right, number 9 and number 10 on the first page. 9 and 10 on the first page. 12, 14, and 15 on the second page. So that's 5 total problems. 9 and 10 on the first page, 12, 14, and 15 on that page. I've got it back up here, Ashley, if you need to copy it down. All right, so please do your homework tonight. If you did not do the algebra nation work, I will let you turn it in tomorrow for a late grade. But you can work on this tonight to try to average out that stuff for my